Welcome to our third episode of the Pollination Podcast. Today is part one of the History of Beekeeping series, where we're going to examine the ancient origins of the honeybee and how it evolved into the species that we know and love today. So the ancient origins of the honeybee began roughly 130 million years ago in the late Cretaceous period. This was a time where dinosaurs were still walking the earth. You had T-Rex and Velociraptor and Triceratops. There were no pollinators at this time. In fact, all plants were completely wind pollinated. Wind pollination is still used today, but it's pretty inefficient. About 99% of all wind pollinated pollen is completely wasted. So sometime during this time period, there was a solitary predatory wasp that was an insectivore. The wasp was named the cicada killer wasp, and it fed primarily on other insects. It's theorized that this insect, during times of food scarcity, began to feed on a lot of this wind-pollinated pollen that was just all over the place. And over a long period of time, over many generations, this wasp began to supplement its diet more and more and more with this pollen, until eventually it was feeding entirely on pollen. The wasp was no longer an insectivore, it became pollinivorous. Pollinivorous means supplementing one's protein intake with pollen only. More than likely, as this wasp and its descendants were feeding on the pollen from these plants, it inadvertently transferred that pollen from one plant to another, aiding in the reproduction of those particular plants. And again, over a long period of time, over many generations, a sort of symbiotic relationship formed between this now proto-pollinator, basically, and the plants that it was foraging from. So this was probably the first pollinator. And plants that became more enticing towards this pollinator and its descendants were more likely to be pollinated. So there was a natural selection placed on these plants to entice these insects to visit them and to aid in their reproduction. And the plants did that by developing ultraviolet markings, because honeybees and their ancestors could see in the ultraviolet spectrum. It made the plants more visible to these insects, so they were more likely to be visited. The plants developed nectar guides, which were patterns or colors or shapes on plants to help guide the insect to where the nectar and the pollen was located. A lot like runway lights that we have at our airports today. The plants also had very sweet scents that attracted the pollinators. These early pollinators also began to develop pollen baskets on their legs, which would allow them to carry greater quantities of pollen. They developed these small hairs on their body that would allow the pollen to stick more easily to their body so that they could bring more back to their particular nest and also transfer them to other plants. Another major turning point in the ancestry of the honeybee was when these solitary wasps, these ancestors of the honeybee, began to work together as a group. They began to form colonies, probably slowly over time, until they developed into what's called a eusocial society. And a eusocial society is the highest level of social organization that a particular group of organisms can have. So they essentially created a new type of organism. This organism is called a superorganism. And I try to explain this a lot to the new beekeepers, that when you see a beehive and you see all these different bees that are in it and all the different varieties of bees, you have your queen, you have your male bees, which are the drones, you have the worker bees, and the worker bees are broken down into many different types of jobs that they have, and these jobs change over the course of their life. All of these different individual bees working together are just a part of the hive itself, and the hive is a superorganism. The hive can generate its own heat through the use of these bees. So an individual honeybee is a cold-blooded insect, but the hive is considered a warm-blooded organism because it's able to maintain an internal body temperature or an internal hive temperature of about 93 degrees Fahrenheit, regardless of the outside temperature. The individual honeybees cannot do that, but together as a group, as a colony, they can do this. The colony is able to reproduce itself by swarming. So when the bees go off to form a new hive, and that is separate from the reproduction that the queen bee is doing, which is she's laying eggs, which is hatching out into the different workers and the drones. So it's very important when you're thinking about how to take care of a beehive that you have to think a lot like the bee does. The bee is always working towards the betterment of the colony, even if it means sacrificing itself. And you can see this in day-to-day beekeeping. You can see the bees that are sick, weak, old, or dying. They generally will do their best to leave the hive so they don't die in the hive to spread whatever disease that might be affecting them. A lot of people don't like doing the varroamite alcohol washes because it forces you to kill a half a cup of bees. As you soak them in this alcohol, it causes the varroamites to detach from the honeybee's body and sort of sink to the bottom of the bowl or whatever jar you're washing them in. And that allows you to count the mites, and you can figure out how infected your colony is through these. And a lot of beginners don't want to do that. They want to do this powdered sugar wash, or they just want to try to examine the brood or what have you. And I really always advise them against that because, yeah, it is sad you've got to kill this half a cup of bees. It's about 300 workers of bees. Nobody enjoys doing that. But if you look at it from the bee's perspective, they would willingly sacrifice their own lives for the betterment of the colony. They do it every single moment of every single day. And by you doing this alcohol wash and determining your infestation level of the varroamites, you can now know whether you need to treat that colony or not to destroy the mites, which is going to better the colony. And that's just kind of one avenue that you have to think about as a beekeeper to take better care of your bees. And that is just you thinking like a honeybee. Because what's most important is this superorganism. It's this hive. So the honeybee that we know today, that most people commonly think of, when you think of honeybees, you think of a beekeeper. If you drive down and you see beehives down the road, that particular species of honeybee is called the Western or the European honeybee. It's also known as Apis mellifera. Apis mellifera is a Latin phrase meaning honey-bearing bee. And it's hotly debated exactly where Apis mellifera originated. There are two competing hypotheses. You have the out of Africa hypothesis, which believes that Apis mellifera originated in Africa and spread upwards. And you have the out of Asia hypothesis, which Apis mellifera originated in Asia and spread throughout there. This is a hotly contested topic amongst honeybee researchers. There are papers coming out almost every year trying to determine exactly when and where the honeybee originated. I will say, in doing research for this podcast, I was pretty well convinced that they more than likely originated from Asia and not Africa. But again, there are strong arguments to be made on both sides. Another hotly contested topic is how many species of honeybee there are. The University of Florida Honeybee Research Lab, which is where I really like to consult if I'm getting the most up-to-date information, recognizes 10 separate species of honeybee. Although I've seen some people state as low as 7, I've seen some people argue as many as 12 species. Kind of all depends on how you want to group or split the different characteristics of the honeybee. And even underneath the species, you have a subspecies group, which is even more hotly debated. There are roughly 30 subspecies of just Apis mellifera. That's not including the other 9 species of honeybee. We're talking about just the one species, Apis mellifera, 30 subspecies within that group. Although some people will argue that there's somewhere in the 20s, some people argue there's more than 30. Again, depends on how exactly you want to group and split this. Some are very clearly a subspecies. If you look at the Italian honeybee, which is one of the most common bees we have here in the United States, it's also known as Apis ligustica. It has very clearly defined traits, right? It has high population, high honey production. It's very gentle. It has some negative behaviors like a high rate of swarming. It has a high rate of robbing, so the bees start attacking other beehives. Those are very clearly defined traits of that particular bee, and it's very obvious that that one fits well within a subspecies. But you have other bees, other subspecies of bees that are a little bit more in a gray area. And the buckfast honeybee, technically it's considered a hybrid, but some people will argue that it is a subspecies. So it just sort of depends on where you fall and how you want to define the honeybees. What a lot of people don't realize is that there are no subspecies of honeybee in the United States. Basically, what we have are breeds or stocks, or you can just call them hybrids. A lot of people will call me and say, hey, what kind of honeybee are you running? I used to say, you know what, they're mutts, because that's kind of what they were. Doesn't really sound as good when you're trying to sell that particular type of bee. Oh yeah, I'm running Italian mutt bees. Not very enticing when these other beekeepers are saying, yes, I run pure Italians and I'm running pure buckfast or whatever, what have you, But the reality is there are no pure subspecies. Any type of honeybee that you can purchase here in the United States is going to be mixed with probably a variety of different species. And if you really think about how far honeybees have spread on planet Earth, they have colonized every single continent in the world outside of Antarctica. They have adapted to polar climates and temperate climates and arid climates and tropical climates, Mediterranean climates and mountainous climates. And they've been around for millions and millions of years. The odds that there are any particular type of species that haven't interacted and interbred with another species or even a subspecies, it's just not very realistic. On top of the fact how domesticated honeybees have been by humans. So when you're purchasing a queen from a queen rearer or you're buying a nucleus colony, don't fret too much over the particular breed of that bee. If you're looking for a honeybee that has particular characteristics, high honey production, high population gentleness, what have you, or resistant to tracheal mites or varroa mites, you kind of have to understand that you're not really getting that in a pure form. Even queen rearers who do artificial insemination of honeybees are not able to control those genetic traits with 100% certainty. What I've learned from raising queens is that all you really are able to do in your particular stock that you're raising of honeybees is gravitate towards certain traits and gravitate away from certain traits. And even that is still pretty tough to do because realistically you're not in an isolated environment that is going to allow you to control those genetics exactly. This vast genetic diversity, however, is probably going to be Apis mellifera's saving grace as far as all of the stressors that are being placed upon them. We have the varroa destructor mite and small hive beetle. You've got foul brood, monocropping, deforestation, herbicide, pesticide use. All these different issues that are facing the honeybee that we've come to know and love, there probably is an answer somewhere in their DNA. That's probably the answer to saving them because they have spread so far across the planet. They're so genetically diverse. The honeybee has proven that it is probably second only to humans as far as its ability to adapt to a global environment. So that can give us a lot of hope for the future that we can find a solution to a lot of these problems. There already may be a particular subspecies or hybridization of Apis mellifera out there right now that can solve a lot of the problems that we're already facing. So I think we'll leave it right there on that positive note. Join me next time when we continue our History of Beekeeping series. I'll be discussing the domestication of the honeybee by humans throughout history. Thank you so much for joining us today on the Pollination Podcast. I'm Matthew Walker from Walk in the Woods Apiary. We hope we have answered a few of your beekeeping and pollinator questions. Please share your questions and comments to our Facebook page at the Pollination Podcast.